In this video, I would like to show you how can we make a few example, a few calculation by using the equation that we had used before, where we can relate the value of G, where G is the gravitational acceleration on the surface of any object or any planet in universe with the G by using the value of M and the value of R, where R is the radius of the object or planet itself, and M is the mass of the object itself. So that means if we want to find the value of G, gravitational acceleration on the surface of Earth, we can use G times M, mass of the Earth, divided by a square of the radius of the Earth. Or if we want to find the value of gravitational acceleration on the moon, G moon, so we can use G, mass of the moon, or and the radius of the moon. And of course, we can use this formula to find the gravitational on other planets or other stars equals to G times mass of the planet divided by square of the radius of the planet. Okay, so we will look into a few example. Okay, I will show you a few example that we can use. Okay, so that you will be familiar with this equation. Okay, first we will look into the method that we use to find the value of G on the surface of Earth. Okay, G on the surface of the Earth. Okay, so I will just use this question. Okay, so this question. So let's do it together. Okay, example number 1 here. Okay, example number 1 here. Mass of the Earth is 5. So let's take out the information there. So mass of the Earth, okay. Mass of the Earth, let's put it mass EME as mass of the Earth is equal to 5.97 times 10 to the power of 24 kilogram. And then we have radius of the Earth. So radius, just put it as RE equals to 6.37 times 10 to the power of 6 meter. 6 meter. And next we have G, where G is the gravitational constant, 6.67 times 10 to the power of minus 11 Newton meter square per kilogram square. Okay, and the question asks us to find the value of G, where G is the gravitational acceleration on the surface of Earth. So just put it as GE, since we are dealing all of the value of Earth. Okay, so let's try. So the first step, as usual, we need to take out we need to determine which equation that we need to use. So here we have ME, RE, G, and G. So you can see here double G. So the only equation that we can use is, okay, we just have one mass. Okay, if you want to use the Newton's law of universal gravitation, where F equals to Gm1 m2 over r square. So F here is not included, so we cannot use this one. And here we have two masses, okay, two different masses. Here only we have one mass, so we cannot use this equation. Okay, the other equation that we have is, of course, the gravitational acceleration. So the equation state that G equals to Gm over r square. So this is, we can substitute the value of G of Earth, M of Earth, and R of Earth. Okay. The next step is we substitute the value. So GE equals to G 6.67 times 10 to power of minus 11, okay, and M square kg minus 2 times the mass of Earth, which is 5.97 times 10 to power of 24 kilogram, okay, and then divide by the square of the radius of the Earth. So square, let's put a bracket there, 6.37 times 10 to power of 6 meter square. Okay, so by using your calculator, then you will get, let's take out our calculator. Okay, so 6.67 times 10 to power of minus 11, okay, times 5.97 times 10 to power of 24, okay, and then divide by square. So let's use a bracket there, square, 6.37 times 10 to power of 6, close bracket, square. So the value that we will get, so what is this? Okay, maybe I had done a few mistakes there. Yes, double square, okay, square. This is not the value, okay. Okay, divide by, so here, just put it square, with symbol for square, here, okay. So we will get 9.81, okay. 9.81344 meter per second square, where the value is approximately equals to 9.81, where the value that we normally use, okay, 9.81. This is the value of acceleration due to gravity on the surface of Earth, okay. Sometimes some student ask me, how can we determine the unit, okay, the unit. So of course the unit also we can get by using this formula, okay, this formula, but we substitute with the unit. Okay, let's put it here, G. So what is the unit for G? Unit for capital G, it is Newton meter square kg minus 2, and then mass is kg, and then divide by meter and then square. Okay, so meter square, we can cancel out kg minus 2 and kg, so we will get Newton kg minus 1. Okay, so what is Newton? So Newton is kg meter per second minus 2. So this is Newton time kg minus 1. So kg and kg minus 1 we can cancel out. So we will get meter per second square. So this is how we can determine the unit of the acceleration. Okay. And this is the value of gravitational acceleration on the surface of the Earth. Okay, let's look into another example. Okay. What we have here, okay, let's try to find the value of gravitational acceleration on the surface of the moon. Okay, on the surface of the moon. Let me just take out all of the information that we need. Okay. So surface of the moon, we want to find G, moon. So by using the formula G equals to Gm over R square, what do we need here if we want to find G, moon? So what we need is G, mass of the moon, and also radius of the moon. Okay, so let's find the value of mass of the moon first. Mass of the moon is equals to 7350 1022. 7350 mass moon 7350 times 10 to power of 22 kilogram, and then radius moon equals to, okay, radius of the moon equals to 1750 kilometer. Okay, 1750 kilometer. Okay, we need to convert to meter because, okay, why do we need to convert to meter? Because here the value of G is equals to 6.67 times 10 to power minus 11 Newton meter square. So you see, here we have meter. So we cannot mix with kilometer. So we have the radius in kilometer. We need to convert it into meter, where 1750 equals to 1750 times 10 to power of 3 meter. Okay, kilo. Convert to meter times 10 to power of 3. Okay. Now we have all of the value. So we just need to substitute. So G moon equals to G 6.637, 6.67 times 10 to power minus 11 times the mass of the moon, which is 6.35 times 10 to power of 22, and divide by the value of, okay, the value of square of the radius. So radius is 1750 times 10 to power of 3 meter, and then square it. So take out your calculator. So where is my calculator? Okay, 6.67. Okay, of course you can store this value, or you can save it in your calculator. Let me save my value there. Okay, 6 4G 6. Okay, where is 6? Okay, I'm not sure. Let me make it later. Okay, just use the value here. So 6.67 times 10 to power of minus 11. Okay, times 7.35. 7.35 times 10 to power of 22. Okay, we get the upper part, divide by square, we put a bracket there, 1750 times 10 to power of 3, and then close bracket and square it. So the square. And then I will get, okay, this number, or this number, which is equals to approximate 1.6, okay, 1.6 meter per second square. So we can compare this number, okay, with, okay, G moon with G earth, okay, and then we will get G moon, okay, G moon is approximately 1/6 G earth, or G earth is approximately equals to 6 times of the gravitational acceleration on the surface of the moon. So that is how we can calculate the value of gravitational acceleration on the surface of any planets, any objects, any stars in our universe, by just only using the value of the mass of the object itself plus the radius of the object itself. So hopefully you can understand, and you can use this method to calculate or to find the value of G for other objects. So thank you.